Hi everyone, I hope that you're having a really good Tuesday. Today's video is going to be pretty short. You have some reading to do in the textbook pages that I posted and a worksheet to fill in, so you don't have to submit that worksheet. It's going to go right in your notes. So we just need to finish up. We are almost in our chemistry unit. It's this video and one more and then we're done. So we just need to finish up the types of reactions that we've been talking about. So far yesterday we talked about four, okay? So we've talked about four different types of reactions that can happen. I'm just scrolling up so that we can see them. So the first one was synthesis. And in synthesis reaction, this is when we start with two separate products and we end with one compound, okay? So two separate products, one compound. Then we had our decomposition reaction, which was the opposite of a synthesis reaction. So this is where I'm going to have my one compound and I'm going to break it down into its pieces. Okay, so I start with something that's whole, break it into its pieces. Next, we talked about our single displacement reaction, and I think that this is the one that most of you might struggle with because honestly, like, this is the one where we can actually have something where we have no reaction. So in our single displacement reaction, something in our reaction is actually going to switch spots. So here, if I have A plus BC, basically my A and my B are switching spots over here. They displace one another. And we need to use an activity series to help us tell if a metal is going to switch with another metal. Okay, so a metal can switch with any other metal as long as it is below that metal in the activity series. Okay, so a metal can displace any metal below it in the activity series. So for instance, lithium can displace everything below it. Gold, not going to displace very much because it's on the bottom. Okay, so that's the whole idea behind the single displacement reaction. We use this activity series to help us predict whether or not a chemical reaction is actually going to occur. So we went through these examples. We talked about, let's just look at, well, we can do this one really quick. Sodium plus water. Okay, so sodium and my hydrogen are going to be, if I'm looking at this, these are going to be my metals right here. So I have sodium, I have hydrogen. Those are my metals right now. Oxygen is going to be my non-metal, so I'm just going to throw a different color underneath it so we know that that's a non-metal. It's a different thing altogether. So what I'm going to do is I'm actually going to find, on my activity series, I'm going to find sodium and I'm also going to find hydrogen. So for instance, right here, what we're looking for in this activity series is that my sodium is higher up on the list than hydrogen. So here is my sodium. Okay. And here is my hydrogen. And I can see that this is higher up than this. Yes, do you guys see that? I know that it's super messy. Sorry. I don't have a flat surface right now. So I can see that that's higher up. What that means is that sodium has enough energy, enough power to displace, to basically knock hydrogen out of its spot down here. So if I'm looking at this, I'm going to have my sodium here. It's going to actually switch places with my hydrogen. So my hydrogen is going to be left by itself, and then I'm going to be left with sodium oxide. Okay, so what happens though, and this again I think is probably the most confusing part, this hydrogen, it's happy, it's diatomic right now, but I need to make sure that this this sodium and oxygen, that they're in the right proportion. And remember, proportion has to do with subscripts, so I need to figure out what subscripts I need here. And in order to do that, I need to do my crossover rule. And if you don't remember how to do this, you A, need to look at the notes that you have, B, send me an email if you still can't figure this out. So the way that I use my crossover rule, sorry about that, the way that I use my crossover rule is actually by using my periodic table. So the first thing you're going to do is you're going to find sodium on your periodic table. It's in that very first column, okay? So that means if it's in my first column, that it's going to have a 1 positive charge. Remember, the plus or minus doesn't really matter here. And my oxygen now, I'm going to find my oxygen, and it's all the way over on the right-hand side of the periodic table. Number 8, it's going to have a 2 negative charge, okay? I'm going to cross over the charges. I don't care about the plus or the minus, and this tells me how many of each I need in order for this to be a valid chemical equation. So here, I'm going to have my H2, right? Plus, instead of just one sodium, instead of just one Na, I need to have my 2 down here. And I'm going to have one oxygen, which I don't really need to write that 1 there because it's implied. Okay, so I'm just going to erase it. So that's my crossover rule, or my crisscross rule. Okay, so now this so far is pretty happy. I'm okay with this. This, though, remember, is a skeleton equation. A skeleton chemical equation. Because it is not balanced. Okay, and we're going to go over balancing equations one more time after tomorrow's lesson. Okay, it is not balanced. So, this is it. This is kind of where I am with making my equation. So, I only have to use this activity series if I'm doing single displacement reactions. Running out of room. Okay. I do not need to use this for any other reactions. So let's talk about some other ones. All right. The last reaction that we're going to talk about in this video, you're going to read about one. It's the most exciting one, which is why you're going to read about it, is called the double displacement reaction. And in the double displacement reaction, instead of only one thing switching, we actually have two separate chemicals switching, two separate compounds, or elements switching. So if I have a compound that's A and B plus a compound that's C and D, what it's going to yield, what I'm going to produce, is AD plus CB. So notice that basically what's happening is that my A and my D are switching, my B and my C are switching, okay? And it happens in a very specific way. So essentially what's going to happen is that the two cations of each of these compounds are going to switch places. All right, so this only works here if this is compounds that have cations in both. Again, remember, cations are things that are going to give away electrons, and we usually see these as metals. So essentially what's happening? Well, both of my metals are going to switch places. All right? Okay. So if I'm looking at this, we are going to have to identify our metals and our nonmetals here. So right now I have lead nitrate and, potassium iodide. So if I'm looking at this, I'm going to want to label which is which. Okay, so here, I have my lead, that's going to be a metal, and I have my potassium, which is going to be a metal. And so now these are going to switch. Okay, so I'm going to have effectively, when I do this, I'm going to have instead of my lead being first, it's going to be potassium. Okay, I'm not done here. All I did was switch my metals. Okay, they switched. Do you guys see that? I'm not done here. What we need to be sure of, and what we want to for sure, make sure that we're doing, is again, I need to use that crossover rule. So I need to use my periodic table to find the charges that each of these compounds are going to have so that I can make the subscripts that I need. Now, remember that there's a couple of ways that I can do this. So the first thing that we should notice is that when I'm looking at my compounds here, I can do reverse crisscross to figure out which charges of these I'm using. So I know that this 2 right here, well, that was really the charge of my lead. Okay. And this 1 that I don't see right here, well, that's really the charge of my nitrate. Right? So the same thing is going to happen over here. This is still going to have a charge of 1. This is still going to have a charge of 2. Okay. I also know from looking at this that I'm not really dealing with any subscripts here. So this was either reduced Or I could use my periodic table right now to figure out that potassium is going to have a charge of 1. And iodine also has a charge of -1. Okay, so I'm going to cross these over. So now this is going to look like KNO3, nothing changed here, plus, I'm going to cross these ones over. Lead, iodine, and there needs to be a 2 on the iodide. Okay, so this is kind of where we're at right now. So, hopefully that's kind of making sense. I'll go through one more example and then you guys can try this on your own. It's really, I think, the easiest of the more complex, we'll say. So this is, I think, is easier than than single displacement reactions. But let's look at the next one. So I have sodium hydroxide as well as hydrochloric acid. Okay. So again, I'm going to just underline my metals here. So sodium is going to be a metal. Oops. So sodium is a metal. And my hydrogen is also going to act as the metal here. Okay, so sodium and hydrogen. So I know that these two things are going to switch. Now, before I go over to the product side, how about we actually just do the reverse crisscross right now? Some things that we need to remember is that this hydroxide is one of those special compounds that we learned about, tertiary compounds, right? And so really there's brackets here that we don't always write, but I like to put them in just so that we can see them. And if I were to uncross this, because there's no subscript beside here, there's no little number here, I'm actually dealing with a charge of 1 on my sodium and a charge of 1 on my hydroxide. And same goes with my hydrogen and my chlorine, right? If I were to uncross these, I have a charge of 1 and 1, which makes my life really easy. And I know that because there's no tiny numbers underneath here. That's where I'm getting these here. Okay, there's those invisible ones that I see. So I'm going to switch my green. So I'm going to have, instead of sodium hydroxide, I'm going to have HOH plus NaCl. Okay. And the last thing that I can do here is I can actually simplify this. What is HOH? Well, it's a common thing that we've seen all the time. I have 2 of those hydrogens, 1 oxygen. So this is actually going to make water. And sodium chloride. This is something that we can actually mix all the time together to make water. So if I'm looking at this, and this is a spoiler for tomorrow's lesson, anything that has an OH in is a base, and anything that starts with an H here is an acid. So whenever I mix an acid and a base together, they essentially cancel each other out. They become neutral, and I'm always going to get water and salt as a byproduct. So this is table salt, and this is water. Okay? All right, so we're having so much fun. Let's just do one more example here. I know you guys are laughing at me. Obviously, I need more excitement in my life. So here I have barium hydroxide as well as sodium sulfate. So I'm going to look at this and we're going to do exactly the same thing. So let's start by underlining our metal. So if I'm looking, I know that barium is a metal because it is on the left-hand side of the periodic table. So is sodium. Okay. And I'm going to throw brackets around my special little friends here. Okay, so I know sulfate is one of those special ones that we talked about. And before we go over, let's look at my subscript. So I do see tiny little numbers here. That means that I need to reverse my charges. So this 2 that was right here on this hydroxide, well, that's telling me that that's the charge of my barium. And this invisible 1 that I don't see here on my barium, that's telling me that that's the charge of my hydroxide. And again, I have those same little numbers over here. So on the outside of this bracket, I don't have any numbers. So that means that my sodium has a charge of 1, which makes sense to us because that's the charge that we know it does have. And my sulfate actually has a charge of 2. Okay. So again, I'm going to switch my barium and my sodium. Okay, so now I have sodium hydroxide plus barium sulfate. Okay, and I'm just going to apply my charges here. So I know that barium has a charge of 2. I know hydroxide has a 1, sodium has a 1, sulfate has a 2. Okay, and now I'm going to crisscross them. So here I have sodium hydroxide. Okay, plus barium. Okay, and we're going to look at this for a second. Now, these numbers, again, I just got from crisscrossing them like this, okay? Now, what do we know? If this is a cation and this is an anion, then really this is making an ionic bond, okay? Or, right? So this is a metal plus a nonmetal. And we know from earlier on in the semester that whenever I have an ionic bond, I'm going to reduce my subscripts, okay? So here I had sodium hydroxide, that one's all good. But because I have a 2 in barium and a 2 in sulfate, I'm going to reduce that so that it's just SO4, okay? Science smiley face. All right. So this is essentially our lesson for today. Again, I'm already at almost 20 minutes. Like I said, I'm going to try to keep it 20 minutes or under every day. This is what we're talking about in terms of our reactions. You're going to go on, you're going to see the worksheet that I've posted on here to talk about combustion reaction. Combustion reaction is something that actually happens very frequently in life. So just read ahead. I put some questions there to kind of guide your reading. And this will help take up that 3-hour requirement this week. So you can look forward to tomorrow. We're going to talk about pHs. So I'll put that up here and then we're done with chemistry. I know a lot of you are asking me like what's going to happen testing wise and your grades. I promise I will have your grades up this week. Like I said, I'm having to go through them and make sure that they are the most accurate kind of depiction of what we've done so far given where everybody is at. So that means that for every single one of you, and I have 90 students, I'm going through and making sure that everything aligns properly. So that's where we're at. I don't know what assessment is going to look like in terms of if there's going to be a chemistry unit test. We haven't really decided as a science department yet, but as soon as I know, you will know. I promise it's not going to be this week. Okay, if anything, it'll be at the end of next week. So nothing this week. I will still give you a review if it's the case that we need that, but I might just move more towards project learning. Okay? Please reach out if you have any questions. Let me know that you guys are alive and doing well and doing awesome physical distancing things. My parents have kidnapped my dog, and because my husband and I are in quarantine because he's a nurse, I can't have him back. So I am rather lonely with my cat who likes to bite me. So I hope that you guys are having good, safe learning and that you're staying out of trouble. Okay? Talk to you for now.